I'm gonna teach you how to build a desktop application using Compose Multiplatform. You will see how to make a network request, handle the navigation, implement some unique components specifically made for this environment, handle mouse events, keyboard shortcuts, multiple windows, how to customize an app icon, a tray icon, how to generate a binary for each platform, and more. Stay tuned. For those of you who are not familiar with the framework, Compose Multiplatform is a technology that allows you to share the UI of your app between multiple platforms like Android, iOS, desktop, and even web. In this video specifically, we're gonna focus on a desktop only. Desktop applications run on a JVM, which is a Java virtual machine, which allows you to use your application on a macOS, Windows, or Linux. So, the first step is to generate the project. We can use a KMP wizard to target only the platform that we need. In this case, I will choose desktop and click download button. As simple as that. As a development environment, I will use IntelliJ IDEA. So, let's just open up the project that we have just generated. When you open up the project, you may see a really simple structure. Like with other KMP templates, we can see a Compose app module that contains a couple of source sets. In this case, since we are targeting only a desktop, we can see common main and a desktop main source sets only. Inside the desktop source set, we have some auto-generated code. The app Kotlin file that contains the UI code for our application, and one more main Kotlin file that acts as a main entry point for a desktop application. If you open up the Gradle build file of this Compose app module, you will see some basic things. We have only one target and two different source sets. On the bottom, we have a new desktop block where we define platform-specific stuff for this environment. By default, this application will be available for a Mac, Windows, and Linux. You can see what kind of app formats we are using by default. When exporting this application for each environment, those are the file extensions that will be used. We can also change, for example, the extension for a Windows and use exe instead of the MSI. I will show you how to export the binary at the end of this video. Anyhow, before we continue furthermore, let's run this simple application to see how it looks like. To run the application, we can open up the terminal and write the command gradle space run. Then, after a few seconds, you will see a new desktop window appearing. Here we have a basic Compose UI with a single button. You can also resize this whole window quite easily. And if you click the red button, then this application will quit. Now, go back to the main Kotlin file for a moment. You can see that we have a single window by default. But that doesn't mean that we can't create another one. It's pretty straightforward actually. We can nest one additional window composable and specify a different title. When we click the red button, instead of closing this whole application, we can just close this single window instead. So, let's create here a new state for that purpose. I'm gonna wrap this second window inside an if check, so that we can show it only if this state is equal to true. After that, on close request lambda will contain the logic to change this state to false, which will immediately reflect on our UI and hide this second window. So, let's run the application once again and check it out. It works great. We can even customize the size of this window quite easily. There are a bunch of different parameters that we can specify as well. So, pass here the state and call a window state class. Here, for the width and height, let's add a custom dimension of your choice. We can even pass an additional parameter to disable window resizing for this second window. Awesome! Now, quit the previous application and run it again. Great, as you can see, the second window is not resizable and has a fixed size dimension. Next, let me show you how you can make a simple GET request on a desktop application. For this task, we're gonna use a popular Kotlin multi-platform library called Ktor. So open up the version catalog file to specify the necessary dependencies. We need a Ktor client core, a networking engine, content negotiation plugin, and also Kotlin X serialization library for parsing network requests and responses. Since we are using a Kotlin X serialization, we also need to apply a plugin as well. After that, open up the project level gradable file and specify that same plugin. Then, inside the compose app gradable file, we need to add that same plugin, but also those other dependencies in the common main source set. Perfect. Now sync the project. Afterwards, in that second window, I will add two elements on the center of the screen. One button to trigger the network request and a text element to display a network response. Above all of that, we can define one state that will hold the value of our network response. But also a coroutine scope to launch the coroutine, because our network functions are actually suspend functions. Great. After that, let's create here a simple class in our project. Then let's configure and implement an HTTP client. Here, for testing purposes, I will use a dummy JSON website and its endpoint to test the network request. Below this client, let's create a new function that will make a GET request towards that same endpoint and return a response in the form of a JSON string. Pretty simple example. Now, go back to the main Kotlin file, and inside the onClick lambda of our button, let's trigger the network request to fetch the data and update the variable with its result. The result should be reflected on that text below the button after we fetch a response. Great, now let's run the application and test it out. In the second screen, just click the button and observe the text down below. As you can see, we have received a response in a form of a JSON string. Everything works great. Now, even though this was a pretty basic and simple example, you get how it works. It's really easy to make a network request actually, and if you have a Kotlin multi-platform application that targets, for example, Android, iOS and desktop, you can also write this networking logic in one place and then trigger it from different platforms, which can really save a ton of time in development. Alright, the next thing that I want to show you here is a navigation. I'm gonna show you how to implement a basic navigation in your desktop application. There are multiple libraries created out there that can help you achieve this same task. The official Compose navigation solution is also available for KMP projects. However, one library that really caught my attention with its simple and really easy to use API is called Voyager, which is why I'm going to show you how to implement navigation with that same library. But of course, you can use any other solution that you think is best for you. Let's go back to the version catalog file, and here I will declare two additional dependencies, Voyager Navigator and Voyager Transitions. This second artifact is used for implementing transition animations when navigating between screens. To declare a screen with this Voyager library, we need to create a simple Kotlin class and implement the screen interface. Then, after that, we need to override a content function, annotate that function with a composable annotation, and specify the UI for that screen itself. Pretty simple. In this case, I will add one additional screen that will accept an argument of an integer type. So, let's create the new Kotlin class, this time a data class because this screen will accept an argument. As before, implement that same screen interface and declare the content for this screen. Now, we need a way to navigate from a home screen to the details screen and pass an argument. So, let's open up the home screen, create a navigator variable that we're gonna use inside the onClick lambda to trigger the navigation. When navigating, we can call push function and initialize the detail screen class by passing an argument in its constructor. Pretty neat. On the other side, we want to print that ID value inside the button text and also implement the logic to pop this detail screen from the back stack and go back to the home screen when we press this button. As before, we can use the navigator object for that matter. So let's call the pop function instead. For more details about this library and more complex examples, be sure to check their official website. Anyhow, the last thing, we need to initialize this navigation library and specify a start destination. But also, optionally, customize a transition animation. So we can do that all from the app Kotlin file. Let's here call the navigator function, and in the constructor we need to pass our start destination, which is in this case, of course, the home screen. In the trailing lambda of this navigator, we can also add a slide transition and pass the navigator. There you go. Now run the application and let's check it out. Voila! As you can see, everything here works as expected, and we are able to move between screens with this slide transition animation. Alright, so the next thing, I'm gonna show you how to implement a list and a lazy list with vertical and horizontal scroll bars. The scroll bar and the scrollable components share a common state to synchronize with each other. For example, a vertical scroll can be attached to a vertical scroll modifier and a lazy column, and on the other hand, a horizontal scroll bar can be attached to a horizontal scroll modifier and a lazy row as well. I'm gonna show you how that works. First, let's implement a simple list with scroll bars. I'm going to create here an example screen and specify that example screen as a start destination of our application. In that new screens Kotlin file, I'm gonna declare a new composable function to implement scroll bars with a simple list. So, in this new composable function, let's create a column, and I will add 30 different items inside. We're gonna apply a vertical and a horizontal scroll on this column so that we can scroll in both directions. Above all of that, let's declare two variables for that matter as well. With this code, we will be able to scroll those items inside the column. But we are still missing scroll bars. And to add the scroll bars and synchronize them with this column list, we need to declare here two more composables, vertical and the horizontal scroll bar. To each one of them, we need to pass the same scroll state that we have already passed to this column itself. Awesome. Now, since those scroll bars needs to be located on top of those items in the column, we're gonna wrap them along with a column inside the box composable and place those scroll bars on top of the column. Now, let's launch the application and see how this works. As you can see, the scroll bars can be moved by dragging the bars and using the mouse wheel or the touchpad. Now, let me show you this same approach, but this time we're gonna use a lazy column instead. So, let's create here a new composable function down below, and instead of using column, I'm gonna add a lazy column instead. We're gonna basically copy this whole code from the previous function, only this time we're gonna modify just a part of it. In this case, we don't need a vertical scroll modifier, but the lazy list state instead. So let's declare that a new lazy list state, and we should also pass that same state to a vertical scroll composable down below. With this, everything should work fine as before, only in this case we are allowed to add as many items as we need without losing an app performance. If you launch this application right now, you're gonna see thousands of items inside the list. But they will be loaded in the list dynamically and not all at once. Great. The next unique component for a desktop environment is a tooltip. So, tooltips allow you to display an extra information in your application UI whenever someone hovers over an element with a mouse cursor. I'm gonna create here a new function and a list with two string items. Then let's add a column, and within that column, for each item in this list, let's create a tooltip area composable so that we can wrap a button inside. In the content lambda of this tooltip, I'm gonna add the button. And as a tooltip parameter, let's specify how this tooltip will actually look like. We can customize this tooltip by specifying its placement and a delay in milliseconds. This delay means that this tooltip will show after that delay of hovering with our mouse cursor. Alright, let's call this function in our screen right now and launch the application. As you can see, when you hover over with your mouse cursor, each button will show a different tooltip message. It looks really nice. Okay, so the next thing I'm going to show you how to observe the keyboard and properly react in your application when a user presses a specific key or a key combination to trigger the shortcut, for example. For this, let's create another new composable function. I'm gonna add here two properties to hold a text for two different text fields. Let's add here a column and place those two text fields one after another. On the first text field, I will add a modifier called onPreviewKeyEvent. This callback is invoked when the user interacts with the hardware keyboard. It gives ancestors of a focused component the chance to intercept the key event. Return true to stop propagation of this event, and if you return false, the key event will be sent to this onPreviewKeyEvent's child. If none of the children consumes this event, it will be sent back on the root key input modifier node using onKeyEvent callback. Here, I just want to observe when a user presses a delete key on the keyboard. I'm also doing here a key event type check, because if you don't do this, then whenever you press the delete button, the lambda will trigger two times, once for the key down and a second time for the key up event. When that happens, I want to reset this first text state to an empty string. Great. Now run the application and let's see how this works. Type something inside this first text field, then switch the focus to this second text field and press delete button. You will notice that nothing will happen, because we need to have the focus on the first text field in order to properly react to its key event. And if I now press this key once again, then the text will reset to its empty state. Perfect. So, if you want to observe a key event for this whole window without having to focus on one of those elements separately, then you can specify on a key event parameter inside the window function. There, I will add an if check for the same delete key. Only this time, I'm not gonna include that key event type check, and I will simply log a message when we press the button. Now, run the application once again. No matter what component is focused now, if you press a delete button, then that log will be triggered because we are observing the whole window now and not just one single element. You will also notice that whenever we press this button once, we're gonna see this print statement two times, even though we have pressed the button only once. That's actually because it's counting key presses for both key down and the key up events. Which is why I do recommend checking for at least one of those two types to avoid duplicate execution. Perfect. Next, I will show you how to observe a single, double, and a long press in your application. I'm gonna create here a new function and paste the code. We can use a modifier which is called combined clickable to add a single, double click listeners as well as a long press listener. Now, let's call this function and run the application. As you can see, the text will change accordingly based on what type of a click we have used here. So far, so good. Alright, so now I'm gonna show you how to implement mouse enter and exit pointer events so that you can add, for example, an animation in your application when that happens. So, create a new function as before, then add a column, Inside the column create 10 items, and for each item we're gonna add a simple text element. For each text element, we want to remember a simple boolean state to indicate whether we have hovered on it with our mouse cursor or not. Inside the text, we want to add the two pointer event modifiers and update the boolean state accordingly. After that, let's also declare one more variable which will animate the background color of this text whenever the boolean state changes. Perfect. So, call this a new function all the way up and run the application. As you can see, as soon as we hover over, the background color of a selected item will update. Great. Now, let me show you how to drag various elements on the screen. We're gonna create another composable function as before. On top of our function, let's declare a variable that will hold the offset values that we're gonna dynamically update with our mouse cursor and the drag behavior. We can again call this same modifier pointer input, and as a pointer, we're just gonna pass here a unit. In its block, we need to call detect drag gestures function and update the offset variable. Lastly, specify an offset modifier so that we can reflect those changes directly on our element. Let's call this function once again and let's run the application. As you can see, when we click and hold the left click, we can drag this element anywhere on the screen, because we are detecting the drag gesture and updating the offset along the way. Now, did you know that there are some default context menu items that are available for each text field element? Whenever you type something inside a text field, you can select that text and show some basic context menu items like cut, copy and paste. What's even better is that we can add our own actions in that context menu component. So let me show you. We're gonna create here a new function. Then inside, let's create and add one text field, as well as a simple text element on the center of this column. Now let's call this function and run the application. You will notice that as soon as we type something within the text field, then we can select the text and press the right click. Then when we do that, a new context menu options will appear: cut, copy and paste. In Jetpack Compose, each text element, on the other hand, is not selectable by default, which means we cannot see those menu options for this text down below. But we can change that. Let's go back to the code. Here we're gonna wrap both of those elements inside the context menu data provider composable function so that we can create a custom action menu. Specify items parameter and call one context menu item. For now, when we click on it, I just want to print a simple message, and that's all. After that, let's also wrap this text element within the selection container composable function so that we can make a selectable text. Great. Now let's run the application and check that out. As you can see, now we are able to see that custom menu item. And our text element down below is also selectable now by default. Perfect. The next thing, I'm gonna show you how to add an app icon to your project. Or to your application actually. It's quite easy. You need to open up the app level gradable file, and inside the native distributions block, we can call macOS, Windows and Linux functions. Inside each one of them, we can specify an icon in a corresponding format which is unique for each environment. Those icons need to be placed inside the root directory of our project. In this case, I can just create a new directory and place the corresponding files there. After that, let's launch the application and check it out. As you can see, now we have a custom icon that we have created for our project. By the way, if you are not sure how to convert a regular PNG or a JPEG image into those icon extensions, just visit Google and type something like PNG to icon converter and you will find a solution. Now that we know how to add an app icon, what about the tray icon? We can customize the tray icon whenever the tray itself is available. We can also add custom actions and even trigger a notification using the tray state. Let me show you. Open up the main function. Here, we're gonna call a tray function only if this variable returns true, just to be safe. Then, for specifying the tray icon, we can use a regular PNG or a JPEG image by specifying it inside the compose resource directory, which is shared between multiple source sets. Then, we can access that same resource by using a painter resource composable and passing that same file that we have added to the drawable directory. If you are not seeing that file that you have added in that directory, be sure to rebuild your project and then it should become visible. Next, we're gonna add two custom menu items for the tray icon. The first one will be used to trigger a notification and the second one to exit this application. For sending a notification, we need to create and remember a tray state. That tray state should be also passed to a tray composable function as well. Otherwise, this may not work. Inside the onClick listener of the second menu item, we're gonna use that same tray state to specify the title and the message of a notification. Perfect. Lastly, let's launch the application to see how it looks like. You will notice a new icon in the tray of our system. And when we click on it, then those two new menu items will appear. As you can see, the same thing works with a Windows operating system. We can also see an app icon in the tray, and we can even send a notification. Everything works great. So far, you have seen quite a few interesting UI components and the customization options for a desktop. There are a lot of more UI elements that you can use to enhance an overall user experience, which is why I suggest you to try it out and experiment yourself. However, the last thing which I want to show you here is how to distribute and export a desktop application so that you can share it with others. When we are talking about distribution and packaging, you need to be aware of a few things. By default, Apple does not allow users to execute unsigned applications downloaded from the internet. Users who attempt to launch such applications will face an error that the file is damaged or something similar. Which is why, if you want to share the app for a macOS, you need to sign it first. I'm not gonna cover that topic in this video. Instead, I will leave a link down in the video description where you can check a step-by-step tutorial on how to achieve that. Anyhow, in the app level gradable file, I have already told you that you can customize which file extension you want to generate for each environment. If you open up that Gradle icon on the right side of the IDE, you can search to find a specific task called package DMG, package MSI, package deb, or others. These are used for packaging the application into the corresponding formats. Note that there is no cross-compilation support available at the moment, so the formats can only be built using the specific OS. For example, to build a DMG file you need to use a macOS, and for building MSI or exe files you need to use Windows. Tasks that are not compatible with the current OS are skipped by default. When the application is generated, you can find it in a directory, compose app, build, compose, binaries, main, and then DMG for a macOS packaging, and for other environments you will see a different directory as well. By the way, there are also other packaging and distribution tasks, like the one that allow you to export your application without an installer. But again, I will leave the link down in the video description so that you can read that in more details. And that's it. That would be all for this video tutorial. I hope that you have enjoyed watching it and that you have also learned a lot along the way. Don't forget to leave a like on this video, it helps me a lot. But also it helps other people who wish to watch quality content about this topic. Thank you for watching.
side.